Hello Internet, welcome to part 3 of our grass shader thing. In this video we are going to be making this have wind. So there's two things I want to do. First, if you look from the top, you'll see there's a line going here. This is because we're just using a billboard and it's just along this one axis. We're going to change that. So we're going to go back and actually change our geometry shader to actually generate that that cross section. And then after we get that, we are going to animate. We're going to do probably the simplest wind animation, which is actually just going to be a skew. So we have effectively a line that defines our grass. So it's going to be along the normal. We have a line from the point. We're going to move that top point around based on some sine and cosine function. And then using that, we should be able to manipulate things. So it may not be perfect initially, but I think we'll make it work. I honestly have no idea how it's going to turn out, but I'm sure we'll get there. So a few other things. I don't know if I mentioned this last video, but there is zero lighting on this grass. I can change this however I want. I was doing some research on that. It looks like it's not easy, but I think we can actually get some lighting on here that is fairly close to what you'd get with the standard surface shader. It'll be gross, but I think we can do it. So that will also be coming in a future video. I also, before we get started, have uploaded, by the time you're seeing this, the code will be up on GitHub. So you can go and grab the code. You'll actually probably be ahead of this video or somewhere around where this video is. But also there's issues open. So if you want a new feature added to this or any of my other projects that are on GitHub, create an issue. And then that way other people can comment on it and vote on it and all that other fun stuff. I don't know how that's going to work, but we're going to test it out. So if you guys want to do that, that's cool. If not, oh well. Anyway, let's get started. So we have this. We've got our point cloud render and our geometry shader. What I'm going to start with is this. Do I want to just start up by making it really gross? Sure, what the heck. So we need 3 planes. So I'm going to up this to 12. So every single point is going to turn into 12 vertices, which is a lot, but that should be fine. There's nothing crazy going on there. Then the other thing I'm going to do is do a float. I'm going to store 2 values here. That's why I have the calculator down here. But we need the sine of 30 and the sine of 60. And then the cosine is actually going to be those values reversed. So we're going to have sine 30 is just 0.5. And then sine 60 is 60 cosine, cosine, what am I doing? So 0.866, 0.866. And so why we're doing this is we want these to be at 60-degree angles from one another. So we're going to have one at 60, and we're going to have another one at 120, which is just this reversed. But then we need the cosine because one of these is going to be along the cosine and one is going to be along the sine. Luckily, they're just reversed, so it doesn't really matter. This specific thing so far is actually good. We don't need to modify any of that. I may not have wanted to do that. Let's do quad 2. Quad 1. I'm just adding this so that I can follow it. We could make this a lot better. We could make a function that generates a quad. That's a possibility. For now, I'm going to leave it this way. And then I may go and clean it up myself, but there's no point in you guys all sitting around watching me try to fix that. That doesn't make much sense. So we have our point plus the perpendicular angle, which we don't need anymore. So this normal perpendicular angle, we don't want to work with that anymore. We want to work with something else. Let's see, a float 3. We're going to be working on the XZ plane. Ooh. Now that I'm thinking about this, this may be harder than I was thinking. Because we have things that are at unnormal angles, they're not on that plane. Shoot, that's gonna be hard. I don't know how we're gonna solve that. So for now, let's just move past that, and I will come back to it. I may come up with an idea. I'm thinking of things, but it's gonna take a little bit of thought. The normal angle is gonna throw things off because we can't just use basic math here. We have to actually get the 2 vectors, and we have one. But I need to figure out how to get the other one. I don't know how just yet. Yeah. Okay. No idea. We'll figure it out. So, this is going to be a plane along, let's say, 30 degrees. So this is going to be R. I was going to think about this, and I'm totally blanking. What was I going to do? Sorry. This is losing my mind. And there's a siren outside, and it is distracting. But that's cool. We're going to do our sine of 30, and our 0, and sine 60. That's kind of gross. I don't like this. Let's do this. So this is just for my sanity, so while I'm writing these, it makes a little bit of sense. Does this make any sense? No. It doesn't. Shoot. Sine of 120. 120 sine. Okay, I'm not losing my mind. That is good. 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 Okay, good. Sorry. It's been a long day, and now I am losing my mind. That's alright. So, those are just opposites of one another. They're just reflections, so that should be good. Now I can actually take that. We're going to say our sine is going to be along our x, and then our cosine will be our y. So this should get us an angle along that. So we should get something kind of, we should effectively get that cross that we were normally getting. I don't know why I'm blanking on what that was called, but I just need to actually copy this a bunch of times. And then it should get mirrored across, and everything should be good. And then we just need another one at 30, or at 60, rather. Like so. And this, assuming I'm doing all of this right, which is a big if, should get us our third triangle. And then, if you remember from the episode 2, we had those crossing, so we had like one here, and then another one like that. So each of those were these planes. So this is quad 3, quad 2, and quad 1. Quad 1 is going to be perpendicular, and then the other two are rotated 60 degrees from that. So effectively, we have 3 planes, or 3 quads, rotated equidistant from one another. Which creates sort of a thing, which I should be able to show if I spread these out a bunch. Or just reduce the number, but it's cooler if I do this. Alright, did that actually work? There's still way too much going on here. These performance is still fantastic. So we can do quite a bit of grass. Guess that's good. Let's see here. Is this correct? I'm thinking no. It might be easier if I use something like that. There we go. So yeah, this is not right. We're doing 60 and 60. Is it because I did 30? Maybe. Maybe it is. Hold on. I think I'm thinking about this wrong. Yeah. All of these should be 60s. Sorry. But one of them needs to be inverted. So what I mean by that is one of them has to be reflected over one of the axes. Yeah, like that. And so that gets us, so effectively what I'm doing is I'm rotating one 60 degrees and then flipping it over one of the axes. So say 90 is our dividing line. If I have something 60, it's 30 degrees across 90. If I flip it across that axis, it's 30 degrees in the other direction. So the total difference is 60. So this should work. I don't know why. I feel like I'm going insane, but we need to regenerate our mesh. Today apparently is not a good day for me to do math. Okay, let's try this a different way. We're going to make 1 so I can actually see what's going on here. All kinds of screwed up stuff. We've got it very skewed. And I think that, so part of this skew that we're seeing is coming from, the skew is coming from that normal, which I'm starting to think we just don't want. So we can actually, wait, what? Oh, perpendicular angle is that's totally something else. Okay, I was thinking that was up. It's not. The normal is up. So how did we get, oh, V1. Ha, got it. Okay, I understand what's going on now. V1 is our up. I don't know why I forgot what that was doing, because I wrote this. And, okay, anyway, that's totally irrelevant. It works now. Perpendicular 1, that means we just need to flip that. And now it should work. There we go. Got it. Okay, so what was happening is, like I said with that 90 being our dividing line, what I had done is that initial plane along the actual like 0 axis wasn't along the 0. It was along 90. So they were both 30 degrees apart and there was a giant gap. That's what was happening. There's apparently some weird triangle thing going on here. So I'm thinking I may not understand how these... I'm really hoping this isn't the case, but I may be misunderstanding how geometry shaders work. Which would be unfortunate. That's not going to help, is it? Okay, that's a little bit better. But it looks to me like, so we're drawing those three quads. It looks to me what's happening is it's taking points from those quads and drawing a triangle between them and one of the other points on a different quad, which we really don't want, because that is going to break all the things. And we can solve that by making quads in the middle and doing that, but I don't really want to. Is there a good way to solve this? I do not know. This is part of the problem with me poking at random things. Sometimes it doesn't necessarily go well. I was kind of hoping this would be super easy, but it wasn't. So, now what? Now that we have this, does it look correct? Ish? It's kind of hard to tell. Let's make it huge. Weird clipping issues, but other than that... Yeah, so there's like extra grass being added here. So it's not totally correct. And that's bugging me. Because I was really hoping it would be. And we're getting like weird stretching. Like you can see this blade of grass here. I don't know if you can see, but this one right here, it's actually getting wrapped around and shooting off into wherever it's going. I don't like that. But I don't know how to fix it. Well, I know how to fix it, I just don't want to. Which is almost as big of a problem. But rather than just sit here and dawdle all day, sure, let's do it. Why not? I didn't really want to do this, but that's alright. So, what we need is to change two of these to be 0. So we've got these subtractions and these additions. We need to now turn each of these into separate quads, or into separate quads. So this positive side and the negative side, on the other hand, those need to be separate. So I'm actually going to move it up like this. So this is going to introduce some extra geometry that I didn't really want. So maybe there's something I can do with this triangle stream. I'm not very familiar with geometry shaders, so I don't actually know. But we are going to make it work. So, V0, V1, this is our quad 3 negative. Which, that's gross, but we're going to go with it. And we're just going to need copies of these all over the place. So there we go. That creates that. And then this here is actually going to end up tying to this version. And since that we have that initial internal bit, so this is going to be the middle shoot of our grass. We're going to have the middle bit, and then we're going to have 2 points on either side, and so we'll create 2 triangles there, and by the end we'll wrap back, and then we'll go back out. So there shouldn't be any of those weird loops, I hope. We'll have to mess with the UVs later, because those are going to be wrong now, because we're assuming things that are incorrect. We could probably... Since I'm going to be copying it, let me get them right, actually. I can pretend like they're 0.5, actually. And actually put them in the center, like so. That's not right. So 0, 0.5, and 0.5. So it will go to the center, and then the other one will continue on the other side. So that should cover that, I think. We're going to find out real quick if this works or not, because I'm kind of hoping it will. Otherwise, we're in a very weird position. Well, I'm in a weird position, and you guys are annoyed. So, move that there, and drop this here. There we go. That's quad 2 done. And then quad 1, we have to do the same thing one last time. Get rid of all of the extra stuff. I wasn't intending on it becoming this gross. This is when it would be a good idea to split this off into a function. We should have done that earlier, but we didn't. So now we get whatever the heck this is supposed to be, but that's fine. We can... Splitting things off into functions is usually a lot easier once you've actually got it working. At least I think it is. So usually I tend to put it off. And it isn't that big of a refactoring job, so I don't usually mind. But okay, so this is correct. We go 1 here, 0.5, 0.5. This is incorrect. It should go from 0.5. So 0.5 is there. We've got the negatives again, which will be 0.5s. And this is just correcting the UVs so we don't get incorrect UV mappings. If I didn't do this, what would happen is each of these quads that we're making would be the full texture, which means we would get 2 grass textures repeated, one on either side, which we don't want. Well, I said I fixed the UV stuff. That was clearly a lie. Yep, that totally worked. What have I done? Oh no. Sorry, this wasn't exactly how I intended this to work out. But it's where we're at. So let's see here. Something's causing it to be very stretched. And I think it's this. Sorry, I didn't need to fix those. That was incorrect of me. So by fixing those, I put 0.5 and 0.5 on both at the maximum and the minimum. So the UV coordinates were between 0.5 and 0.5, which means nothing actually happened because there wasn't much there. So by taking that back out and not being a silly person, we should fix it. 0.5, 0.5, 0.5, cool. And there we go. So we have 3 of them working. And then the other ones aren't working because we only limited our max vertex count to 12. Now that we added 2 quads per, we need to up that to 24. And now we get our split grass and it all looks great. Cool. So minor detour, everything was awful, but now it works. So now that we have this, let's kick this back up to ton, drop the grass offset off so it's not on the ground anymore. And that's not going to work. I didn't mean to do that. I just put 30,000 grass objects in a 1x1 square. And we're drawing the wireframe for all of them. This is bad. Let's turn that off. Please? Please don't crash. Okay. So the issue here is there is so much overdraw going on right now. Like the same thing is drawing one thing 30,000 times, which is just absurd. There's no reason that that should be happening. And so Unity is hating me right now. But we're about to fix that. So the reason I keep moving the position is we have it so that it regenerates when we move positions. All right, cool. So this is good now. We have, you'll notice if I go up, we get sort of a radial blank spot instead of the normal lines that we were seeing. And I can move around and it looks normal from as long as you don't go up. This looks relatively normal. So that's good. It's doing what we intended it to. So now what we need to actually get everything animating, there's this V1 here. V1 is the top point in the center of our grass. So what I want to do is I want to animate this. And so we are going to not do that. We are going to do a float 3. We're going to calculate a wind value, which is going to be the amount of manipulation, I guess, the wind has had on the vertex, on the vertices. And we're just going to do 1 and... what do I want to do? Let's just do like a sine and a cosine. So a sine of the time.x times, or we'll just add actually our position. So input, we can actually just use V0. V0 dot x plus V0 dot z, I guess. Sure, why not? I guess that works. And so what I'm trying to do here is just introduce something that is not, it can't be random, but I want it to be unique. So this way, hopefully, things are related by their x and their z coordinates in some sort of way. So things nearby with x and z will be animated similarly, but not exactly at the same time. It'll be based slightly off of their position. So depending on the period of this sine wave, you'll get different effects, but it'll look like it's moving across it like a wave. And we can do some like Fourier Series to actually get this looking more like a wave. But for now, we can just do V0.z and just multiply it like that. And then V1 plus equals the wind times our wind strength, which we don't have yet. And yeah, that should be good. So wind strength, that is going to be coming in, and that's just going to represent how far, at the maximum value, how far we can actually move this thing. So wind strength. Let's make it a float, and we'll just initialize it to like 0.005. So it's just a light breeze. I think it'll be light. Granted, keep in mind, the amount of wind strength is not based off of the height. So it's not a scaling value. It is based off of the wind. So if you crank that up to like 10 and your grass is super short, it's going to look a little bit funky. I would have expected that to do something, and it didn't. So I am missing something. Unrecognized thing, pragma alpha test. Yeah, I know. That's broken. I tried to make these a cutout shader, and it didn't work. Anyway, what am I doing? Wind. Why isn't wind working? Wind plus the wind strength. Do I just need to crank it up? I guess we can find out real quick. So this... Ooh, that looks really funky. Can you guys see that? Yeah, let's make... Oops. So if I look at like the standard Unity ball, it looks super freaky because we're drawing each point on that Unity ball as a grass texture based on the normal. Which actually kind of gets you like a fur texture going on. Probably not a very efficient fur texture, but it looks like a fur texture. So that's unique. wind strength. Yeah, I'm not seeing anything. Oh, right. Ha. Ha. Wait, hold on. If I play this, it's still not doing anything. I've had issues where animated materials do not play at all unless you're in play mode. I think I may be missing something though. So this time should have the time from Unity. Let me go pull that out because I don't think this is getting updated. And maybe it's just because it doesn't get updated in your geometry shader. Which if that's the case, then we have some other things to do, which I'm not too excited about. It would actually make this really hard. But we'll see what we can do here. But I think there's a way to get that working. And if that does work, we should be good. So I'll be right back. Spelling matters. This is stupid, but I had spelled the property wrong. This property. Yeah. Yep. There's the problem. So, because of that spelling mistake, this value down here never got initialized, so it was constantly 0. Which what that meant was we were just zeroing our function because we were solving for this, and then we were multiplying it by 0, which removes everything. So, my bad. If you caught that, then sorry. But now we have it's gonna look a little bit funky because right now it's completely based off of those sine waves, and it's just a single sine, so you can actually see the waves going across, which is interesting. It looks kind of more like an ocean than anything else, but yeah, you sort of get the idea here. You get where we're going. Let's see here. What else should we do? So I was talking about Fourier Series before, and the way a Fourier Series works is it's not actually that special. It's just a summation of multiple sine waves or cosine waves or whatever at different periods. So what a period is it's how fast or how often something repeats. So if you look at like a standard sine wave, so if you just do sine of x, that's going to have a period of 2 pi, which means it's going to take 2 pi before it completes a full cycle of that graph. So if we do one that has 2 pi, or if we do a normal sine wave, so sine of x, and then add on something with, say, sine 2x, that's going to have a faster period, so it's going to repeat faster, which is going to modify how that whole thing looks. It's going to change the entire equation. And so if you just keep adding those one on top of the other, that's called a Fourier series, which is what we're going to do. So if I do time x, I changed all of these because I was debugging and getting concerned. But anyway, so we have v of x and v of z, or the z position and the x position, I guess I could call them. That would make more sense. If I take both of those, let's multiply this by like 2, sure. And then do the same thing over here. So what I'm doing is putting one of these on a different period than the other. I don't know what this will look like. I've never tried it, but we're going to find out because that's what we do. So sine of that, we did z there. So let's do x here and multiply that by 2. So this should get us something a little bit more interesting. I'm going to need to multiply this by something because that's super slow. let's make a wind speed. Make sure we spell this one right. Wind speed float of 0. Well, we're going to want it big. So we may need to insert some sort of constant here or something to increase this, because I don't necessarily want this to be... I don't want to just expose this implementation directly to the people implementing this necessarily. It'll be faster to do that, but then it gets screwed up. So let's see here. All of this, we actually want to move this inside of our signs. So the period is going to be based off of the wind speed times or plus a few other things. And I may not want to do it this way. We're going to multiply the time by our wind speed, not everything else. So we want it to increase or change over time at a faster rate, but not necessarily just increase the variance. We can add another variable to do that. And this is, we may want like a wind map or something to actually map out these behaviors, because this is going to get crazy. Visual Studio, if you would stop doing that, that would be fantastic. All right. There we go. So, I guess on a really blustery day, that looks all right. It's a little bit janky, very fast, but it does actually kind of look a little bit like wind. We don't have, we can't tie directly into Unity's wind system because I don't think that's possible. I haven't found a way to actually get those values. So this looks like the best we can do is just provide these. We can actually write a script that will grab those. And so, because in Unity you can set a wind object. So I can do a wind zone and do like area wind zones and whatever. And this will actually affect like your speed trees and things like that. But there doesn't seem to be a way to actually get that in your shaders or anything really. So we're kind of stuck with our implementation, which, I don't know, this looks kind of cool. It still looks, there's still a pattern, and you can, when you go above it, you can kind of see it is repeating and it's doing all of that. But as we add more things and add, like, if I added like a really slow wave that kind of like progressed this way maybe, it would be really hard to tell. So let's try that. So what if I do a wave inside of a wave? So time dot x plus v0 dot x. Sure. Times our wind speed. No idea what this is going to result in. Absolutely nothing. I don't think I saved. Hit save. Okay. I don't know. That didn't really seem to do anything interesting. Maybe it did lower down, but nope. Okay. Anyway, point is we can tweak these. That wind function, all you have to do is tweak that value, how that's calculated, and you'll actually get different things. We could assign that to some sort of texture, do a lookup into it, and actually get these some interesting offsets. That's how I've traditionally seen it done. But I just wanted to mess around with this. And then just adding the motion really helps. The next thing I want to do is actually make this so you can actually trample it. So we have, when we were making our displacement maps for our deforming terrain when you stepped on it, we already made it so you could actually write to a map when something collides with something. So what I want to do is use that map, plug it into this, and then based off of that map, we should, big emphasis on should here, but we should be able to actually look up how deformed this is. So if like a truck drives over this, we can actually write to deform these graphs and actually bend them over. and then we can actually raise them up over time. So you can actually, like, theoretically, you'd be able to track somebody through this. Don't know how actually feasible that is, but we're going to find out. That's coming up. So that's it for this episode. It did not go smoothly, but that's sort of the way it goes here. I'd make all of this stuff up as I go. Like, I have a general idea of what I want to do, but I've never, like this, never done it. The point cloud thing, yesterday was the first time I was rendering a point cloud in Unity ever. So hopefully that's cool with you guys, because I'm going to keep doing it. So yeah, if you want to stick around and learn more, then go for it. But I'll be here. So if there's anything else you guys want me to improve on, anything you want me to change, anything you think that would make this better, let me know, because that's how I get better. So that's it for now. So until next time, see you, Internet.